Section 3.4 is over the quadratic formula. The quadratic formula I think you're really going to like because the quadratic formula is a way to solve any quadratic equation. As long as it is written in this form, ax squared plus bx plus c equals 0, you can use the quadratic formula to get the answer, to figure out where the parabola crosses the x-axis. And the formula for the quadratic formula is not this. That's just the standard form equation. It's got to be in standard form. And here's the actual answer. So remember, our answers are x equals. Here's how it goes. It's negative b plus or minus the square root of b squared minus 4ac. All of that is underneath the square root. And then the whole fraction, not just the b squared minus 4ac, the entire top part is on top of the fraction, and that is divisible by, or divided by, 2a. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the formula we're going to use to solve any quadratic equation. All right, so let's try it. So solve x squared plus 3x equals 5. Right now it's not equal to 0. In order for us to use the quadratic formula, it's got to be equal to 0. So we got to move the 5 over to the other side. We're going to do that by subtracting the 5. So we'll have x squared plus 3x minus 5 equals 0. Now, just so we're clear, let's identify what a is equal to, what b is equal to, and what c is equal to. You don't have to do this on every problem, but for this one we will, just so we're clear on what each variable is. Okay, so remember, a is always the number in front of x squared. If you don't see a number, then it's 1. b is always the number in front of x, so that's 3. And then c is always the number without a variable, in this case, negative 5. So these are the three numbers that we're going to use when we put them into our quadratic formula. Okay, so it's x equals, so we've got the opposite of b, so b is 3, so we're going to have negative 3 plus or minus the square root of b squared, so we're going to have 3 squared minus 4 times a, which is 1, times c, which is negative 5, and that whole thing gets divided by 2 times my a value. A again is 1. Okay, so let's work on cleaning this up. We still have the negative 3, so we'll have x equals, we got negative 3 plus or minus the square root of 3 squared is 9. Negative 4 times 1 times negative 5 is a positive 20. And then that is over 2, because 2 times 1 obviously is 2. We can keep going with this. We can do the 9 plus 20. So negative 3 plus or minus the square root of 29 all over 2. Now 29, remember our square root rules, 29 is not a perfect square. And it's not divisible by 1 either. So I would say that this answer right here, negative 3 plus or minus the square root of 29 all over 2, that is your final answer because it's simplified. There's nothing else that can be taken out of that square root, and then there's nothing else to do. So negative 3 plus or minus the square root of 29 all over 2 would be your answer there for number 1. It'd be kind of hard to see that with a calculator or get an exact answer with a calculator, which is why the quadratic formula works so nicely in every case. You get an exact answer every time. All right, let's try another one. 25x squared minus 8x equals 12x minus 4. Okay, so we got 25x squared. Again, we need everything on one side. So I'm going to move everything to the left side. I want to keep my x squared positive. Okay, so I'm going to do that by subtracting 12x and adding 4. So subtract 12x, negative 8x minus 12x is negative 20x. And that is going to, whoops, I forgot the 4, didn't I? And it's going to be plus 4 equals 0. And we can go from there. So let's start with our quadratic formula. X equals, we got the opposite of b, so negative b. B in this case is negative 20, so we're going to have positive 20 plus or minus the square root of b squared, so negative 20 squared minus 4 times my a value. A is 25 in this case, times my c, which is 4. Okay, that's c. And that whole thing gets divided by 2 times my a value, which is 25. So it's not always going to be 1, but that's okay. It's still the same formula. Okay, so let's move on here. X equals, we get 20 plus or minus the square root of, let's see, negative 20 squared means negative 20 times negative 20, which is positive 400. Negative times positive is a negative. 4 times 25 is 100. 100 times 4 is 400. And something nice is about to happen. 2 times 25 is going to be 50. Okay, 400 minus 400 is 0. They cancel each other out. And then the square root of 0 is 0. So this whole thing becomes 0. So we're just left with 20 over 50, which we can drop the zeros, leaves us with 2/5. So in this case, we only have one answer. Okay, and that is perfectly fine. If we only have one answer, what that means is that my vertex is at the x-axis. So if I was going to graph it, it would look something, whoops, not like that. It would look something like this, where the vertex is the only point on the x-axis. So it's going to be fine if you only have one answer. It just means that your vertex is at the origin, or not the origin, the x-axis. Okay, let's try another one here. Number 3, negative x squared plus 4x equals 13. Again, we got to move the 13 over, so we have negative x squared plus 4x minus 13 equals 0. Do you have to move everything to the left every time? No, I just get in the habit of doing that. If you want to move the x squared over to the other side to make it positive, you can certainly do that. Okay, so let's fill in our quadratic formula. X equals negative b, so b is positive 4, so then the opposite is negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is negative 1 this time, times c, which is negative 13. And all of that gets divided by 2 times our a value, which is negative 1. Okay, so let's keep simplifying here. Switch to green. X equals, we still have negative 4, plus or minus the square root of 4 squared is 16. Negative times negative times negative is a negative. 4 times 1 is 4. 4 times 13 is 52. And all of that gets divided by negative 2. 2 times negative 1 is negative 2. Okay, so let's keep going. We can do 16 minus 52, and what that's going to give us is negative 36. And all of that gets divided by negative 2. Okay, so now we can keep going, because 36, while it's negative, it is a nice number because it's a perfect square and it's negative. We know how to handle negatives underneath the square root. That was section 3.2. That was imaginary numbers. The square root of 36 is 6. And then to handle the negative, we put an I out front. So x is equal to negative 4 plus or minus, this is now 6i, all over negative 2. Now, if you want, you could divide all of these by negative 2, or by 2, because I guess we use negative 2. That way we can clear out the denominator. So negative 4 divided by negative 2 is a positive 2. And instead of plus or minus, technically it would become minus or plus, but really it doesn't matter. Plus or minus, and again, 3i. So your answer here is an imaginary one, 2 plus or minus 3i. Now, what I want to draw your attention to is the 3 different types of problems. In problem number 1, we had 2 different answers. We had 2 real answers, negative 3 plus or minus the square root of 29 all over 2, which is 2 answers. It's negative 3 plus and then negative 3 minus. Okay, in the second equation, the second example, we only had 1 answer. Okay, and then in the third equation, we had technically no real answers. We had 2 imaginary answers. So then the question becomes, well, how do you know which one is going to happen? Okay, and that's what leads me to the one vocabulary term in the section, which is discriminant. Okay, the discriminant determines the number and type of solutions, and I should say to a quadratic number and types of solutions a quadratic equation has. Never mind, I don't even read my own typing. Determines the number and type of solutions a quadratic equation has. Okay, so the discriminant is this. It's the number under the square root, b squared minus 4ac. It is not the square root of. It is not that. It is just b squared minus 4ac. It's just the number under the square root, because that determined everything. If this was a negative, then we had imaginary. If it was exactly 0, like this one was, then we had 1 answer. And if it was positive, we had 2 different answers. And that's kind of the summary for the discriminant. If b squared minus 4ac is greater than 0, if it's positive, then we have 2 real solutions. If the discriminant b squared minus 4ac is equal to 0, that meant we had 1 real solution. And then in the last example, b squared minus 4ac was less than 0, which meant we had, well, we could think of this one of 2 different ways. We could say it's 0 real, or we could say 2 imaginary. Either one would be perfectly acceptable. Okay, so It's all based on the discriminant, the number underneath the square root. If it's bigger than 0, 2 answers. If it's equal to 0, it's 1 answer. And if it's less than 0, you got no real answers or 2 imaginary solutions. Okay, so in this section, we're also going to be asked to find the discriminant and determine the number and type of solutions. Notice it's not asking you to find the solutions, it's just asking you to tell me how many and what type of solutions this equation would have. Okay, so that is based on the discriminant. So we're going to start with b squared minus 4ac. Okay, here's a. A is actually in front of x squared. There's b, there's c. Let's fill it in. It's all plug and chug. So we're going to have negative 6 squared minus 4 times my a, which is 1, times my c, which is 10. So we do negative 4 times 1 times 10, which is going to be negative 40. Negative 6 squared is 36. 36 minus 40 is negative 4. So if my discriminant is a negative number, this one, what that tells me is that I'm going to have, you can write it one of two ways. You can write it as 2 imaginary, that's a G, 2 imaginary, or you could write 0 real. Either way is fine. Okay, let's try another one, number 2. So here's A, which is 1. B is negative 6 again, and this time C is 8. Okay, so we'll do b squared minus 4ac. We'll start with b is negative 6 again, so negative 6 squared minus 4 times my a, which is 1, times my c, which is 8. Negative 6 squared is 36. Negative 4 times positive 1 times positive 8 is negative 32, and then 36 minus 32 is 4. So if it's a positive number, if we go back to our chart here, if b squared minus 4ac is greater than 0, that means we are going to have 2 real answers. Do I know what they are? No. Am I being asked to find them? No. All I need to know is how many and what kind. Okay, let's try another one here. Number 3, 4x squared plus 8x plus 4 equals 0. Again, b squared minus 4ac. Here's a, here's b, here's c. So we're going to start with 8 squared minus 4 times my a, which is 4, times my c, which is also 4. Let's see, 8 squared is 64. Negative times positive is a negative. 4 times 4 times 4, if you type that in your calculator, it is 64. So then 64 minus 64 is equal to 0. And if your discriminant is 0, if you go back up and look, b squared minus 4ac equals 0. That means we have 1 real answer, which means the answer, wherever it might be, means the vertex is on the x-axis. Let's try one more here. 5x squared equals 8x minus 13. In order for us to do the discriminant, we've got to have everything on one side. It's got to be equal to 0. So I'm going to move the 8x and the 13 over. So 5x squared minus 8x plus 13 equals 0. And then we can go from there. It's the same problem. Here's A, here's B, here's C. So remember, it's b squared, so we're going to have negative 8 squared minus 4 times my a value, which is 5, times my c value, which is 13. So negative 8 squared is 64. Negative times positive is a negative. 4 times 5 is 20. 20 times 13 is 260. Go ahead and use your calculator for that if you're not sure. And then 64 minus 260 is negative 196. If your discriminant is less than 0, what that means is you have 2 imaginary solutions. For some reason the G is not writing well. 2 imaginary, or you could write 0 real. Either one is perfectly acceptable. All right, the last thing in the section is the vertical motion models. Okay, the first one, the dropped model, is actually introduced in section 3.1, but I skip it because it does come back again in section 3.4 where we add the launching or throwing. Okay, so the model, if an object is dropped, is here's the equation. It's h equals negative 16t squared plus h sub 0. Now, the h sub 0 is just notation. The 0 means nothing in terms of a number. And I'm going to explain what all of this notation means in just one second. If the object is launched, or you can think about if it's thrown, so h equals negative 16t squared plus v sub 0 t plus h sub 0. Okay, again, v sub 0, h sub 0, they're just notation. They don't actually equal 0, but I do want to introduce you to this notation because you do find it every once in a while, especially when you get into physics. if you pursue physics class here in high school or in college. You will see that notation often. Now, let's go and define what all these variables represent. H. So the H value, the one it's equal to, is you could call it the current or target height. Current or target height. Okay, current or target height. The V sub 0, actually let's go to H sub 0. H sub 0 is the initial height. Initial height. And most every problem will give you that information. It's just a matter of replacing that variable. Okay, V sub 0, well, if H sub 0 was the initial height, V sub 0 makes sense that it would be the initial velocity. Initial velocity. Okay, one thing as a side note with initial velocity, if something is going up, that is a positive. It's a positive velocity, and if it's down, that would be a negative initial velocity. So that's something to keep in mind as well. And then the last variable that we have to define would be t, and we've got t in several places. T, just like every t in every context of a question, stands for time, and this time is in seconds. Okay, because the negative 16, if you notice both of them are negative 16, that would be this is gravity right here. That's the gravity's effect on the object. So it's always going to be negative 16. You don't have to worry about changing that number. It's always going to be negative 16. So H is equal to the current or target height, H sub 0 is the initial height, V sub 0 is the initial velocity, and T is time. Okay, so let's do an example here. A juggler tosses a ball in the air. The ball leaves the hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. The juggler catches the ball when it falls back to a height of 3 feet. How long was the ball in the air? Okay, so there's a lot of information here. Let's try to figure out what is important. Okay, I'm guessing 4 feet above is going to be important. 30 feet per second is going to be important. And 3 feet is also going to be important. Okay, the question is asking how long was the ball in the air. So the variable we're probably going to be looking for here is t. It's time, because it's asking how long was the ball in the air. Okay, so the ball leaves the hand 4 feet above the ground. Is that the initial height, or is that the target height, or the current height? I would argue that this is the initial height, so H sub 0. Okay, 30 feet per second, that's a velocity, and we're throwing it upwards, so that's going to be a positive 30. And then a height of 3 feet, I'm going to say that that's just going to be H. That's the current height, where he catches the ball. Okay, so if we go back to our formula, obviously we're tossing it, so we're going to use the longer version. H equals negative 16 t squared plus V sub 0 t plus H sub 0. Let's go ahead and fill everything in that we know. Okay, so our current height is 3 feet, and that's equal to negative 16 t squared plus our velocity. We're throwing it upwards, so it's 30, and then we're going to have a t plus, and then our initial height is 4. Okay, well, if we're going to solve this, obviously this equation needs to be equal to 0, so I'm going to have to move the 3 over by subtracting. So 0 equals negative 16t squared plus 30t plus 1. Okay, well, we could try to factor this, but that might take a while. And even if it's possible, I'm not sure, I doubt it. So then the question becomes, how else could we solve this? And since we're in the section about the quadratic formula, I'm thinking maybe we should use the quadratic formula to solve this problem, solve this equation. Okay, so let's go ahead and do that. Here is our a value, here's our b, here's our c. Let's just go ahead and plug it all into the formula. Instead of using x, we'll use t, but it's t equals, but the formula is the same, negative b, so the b value is 30, so we're going to have negative 30 plus or minus the square root of 30 squared minus 4 times our a value, which is negative 16, times our c value, which is 1. All of that is going to be divided by 2 times our a value, again, negative 16. Okay, keep going. So we got negative 30 plus or minus the square root of 30 squared is 900. If you don't know that, just put it in your calculator. Negative times positive is a positive. 4 times 16 is 64. And then 2 times negative 16 is negative 32. If you want to go farther, you certainly can. Negative 30 plus or minus the square root of 964 all over negative 32. Now, at this point, this would be an exact answer, but we're kind of looking for a number here because it's asking how long was the ball in the air. If we just say, oh, it was negative 30 plus or minus the square root of 964 over negative 32, that doesn't really tell anybody anything other than, okay, it's an exact answer, but nobody recognizes what that value is close to. So here's what I'm going to say you do. Use your calculator. So we'll go t equals negative 30 plus the square root of 964 all over negative 32. And then we'll have one that has t equals negative 30 minus the square root of 964 all over negative 32. I have no idea what the square root of 964 is. All I know is that you can use your calculator to come up with an answer here. And I would recommend that you do that. Just make sure that you type the numerator in parentheses before you divide by negative 32. Go ahead and type those in your calculator. What you're going to find is that t for the left one, if you do negative 30 plus the square root of 964 all over negative 32, you're going to get something along the lines of negative 0.03. And that's not really going to make sense because you can't have a negative time, just like you can't have a negative distance. You can't go backwards in time. So this one is probably not going to be our answer. If you do the second one, the negative 30 minus the square root of 964 all over negative 32, what you're going to find is that t is approximately 1.91, and that makes more sense. It's a positive time. The ball was in the air for approximately 1.91 seconds, or you could say about 2. But if you're given a problem like this on a quiz or test, I would definitely want you to round to at least 2 decimal places, unless otherwise specified.